My dear students, how are you all? We have learnt 6 chapters till now, isn't it? We completed first 5 chapters and also chapter 10 time. Now let's learn chapter number 6, which is multiples and factors. So children, what you see here is the mind map for our chapter multiples and factors. So under multiples and factors, we would learn about factors, how to find the factors, the common factors, and HCF. HCF is highest common factor. Then we would learn about multiples, how to find multiples, common multiples, and LCM, this lowest common multiple. Okay, then we would learn about prime factorization, prime and composite numbers, relationship between HCF and LCM, and at last tests of divisibility. Okay, first let's learn multiples. You all know multiplication table, right? If you know, it would be easy. Okay, so here I have shown 7 into 2 equal to 14. Here 7 and 2 are the factors of 14 and 14 is the multiple of 7 and 2. So the product will be the multiple always, and the numbers which are multiplied are called as factors. So this is about factors and multiples. So children, let's learn about multiples. So multiples are very easy. If you want to find a multiple of one number, multiply that number by 1, 2, 3, 4, 5, etc. Okay. So let's find the multiple of 8. How to do? Multiply 8 by 1. So 8 into 1 is 8. 8 into 2 is 16. 8 into 3 is 24. And 8 into 4 is 32. So all these values are the multiples of 8, and these are first 4 multiples of 8. So whenever you get questions to find multiples, multiply the given number with 1, 2, 3, etc. Okay. So children, now let's learn some facts of multiples. First one is multiples are product of numbers. I've told you earlier. For example, 5 into 4 equal to 20. So here 20 is the product. So 20 is the multiple of 5 as well as 4. Okay? Take any example and the product would be the multiple of those numbers which are multiplied. Okay, the second fact is every number is a multiple of 1. Every number is a multiple of 1. The third fact is every number is a multiple of itself. Okay, every number is a multiple of itself. For example, 256 into 1 is 256. Fourth fact is multiple of a number is always greater than or equal to the number. I have given an example of 8. So what were the multiples of 8? 8, 16, 24, 32, etc. So all the multiples are greater than 8. Okay? And next fact is a multiple of a number is exactly divisible by that number. See this example. Here the multiple is 20. 20 is exactly divisible by 5. If you divide 20 by 5, we get the quotient as 4 and the remainder is 0. If the remainder is 0, the meaning is it is exactly divisible. Okay? So, always the multiple of a number is exactly divisible by that number. And the last fact is the multiple never ends. We can multiply and keep on multiplying, isn't it? So multiples never end. We can multiply it how much ever time we want. Okay? So let's see what are the first 5 multiples of 45. What you have to do? You have to multiply 45 with 1, 2, 3, 4 and 5. That's all. Okay? Let's start. So 45 into 1 is 45. 45 into 2 is 90. 45 into 3 is 135. 45 into 4 is 180. And 45 into 5 is 225. So this is how we can find the multiples of a particular number. Okay? So children, now let's check whether one number is a multiple of another number. Okay? Here I have a question. Is 142 a multiple of 4? So how to do that? You have to divide 142 by 4. First, do the division. You all know division, right? Yes. In the same way, do the division, and at last you will get a remainder and a quotient. Okay? So here I have got the remainder as 2. Since the remainder is 2, 142 is not completely divisible by 4. Okay? So 142 is not a multiple of 4. But if you get the remainder as 0, then we can conclude that the number is completely divisible by another number, and that number would be the multiple of the other number. Okay? Now let's see about common multiples. Okay? Here let's find the multiples of 2 and 3. Multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, etc. How to get this? 2 into 1, 2 into 2, 2 into 3, 2 into 4, etc. Okay? The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, etc. Okay? So, are there any common multiples in 2 and 3? Yes. What are they? 6 is common, 12 is common, 18 is common. Okay? And so on. So, here we have first 3 common multiples. They are 6, 12 and 18. So, if you get any 2 numbers or 3 numbers, first write all the multiples of the given number and then find the common multiples in it. Okay? So, this is how we find the common multiples of given number. So, next let's learn about LCM. What is LCM? Lowest common multiple. Okay? So, have you seen alarm clock? Yes? Do you keep alarm? Some of you do it, isn't it? Okay, how many of you wake up at the first ring of the alarm? Very few, isn't it? You keep alarm in your phone also. Yes? So, in the phone, there are option to snooze, isn't it? So, you can snooze and it automatically keep ringing at what time we set to snooze, isn't it? So, let's keep the alarm for 6 o'clock. Okay. Take 2 phones and set the alarm for 6 o'clock. And keep the snooze time for one alarm 2 minutes and for the other alarm 5 minutes. Then for the alarm for which we have kept for 2 minutes, that would ring first at 6 o'clock, then at 6:02, then at 6:04, then at 6:06, 6:08, 6:10 and so on, isn't it? And the other alarm where we kept the snooze time for 5 minutes. First it will ring at 6 o'clock, then at 6:05, then at 6:10, then 6:15, etc. So what is this? These are multiples of that snooze time, isn't it? So that is multiples of 2 and multiples of 5. Yes? So I have written the multiples of 2 and multiples of 5. So this is called as listing the multiples. Here, if you observe, which is the common multiple? Yes, it is 10. And next common multiple is 20. So which is the least common multiple? It is 10. So we can conclude that the LCM of 2 and 5 is 10. Okay? So let's see an example to find the LCM. Here I have 20 and 25. Let's find the LCM of 20 and 25. Yes? So, first list the multiples of 20 and 25. Here multiples of 20 are 20, 40, 60, 80, 100. How to get it? 20 into 1, 20 into 2, 20 into 3, 20 into 4, 20 into 5. List those multiples. And next, multiples of 25. 25, 50, 75, 100. Multiply 25 with 1, 2, 3, 4, 5, etc. Up to which number? Till you get a common number. Okay? So, here we have a common number which is 100. Isn't it? Before that, there are no numbers which are common. So, the LCM of 20 and 25, that is the least common multiple of both 20 and 25 is 100. Okay? So children, our next topic is factors. In the beginning of the class, I have told what factors are, isn't it? I had shown an example of 4 into 5 is 20. In that, 20 is the multiple and 4 and 5 are the factors of 20. Okay? The numbers used to multiply are called as factors. So children, I have a few pens here. Okay? So, in what all way can I arrange this pens equally. Let's see. So we can arrange one row of 6 pens. Okay. One way of arranging is one row of 6 pens. And the next way of arranging is 6 rows of 1 pen each. So there are 6 rows, and in each row there is 1 pen. So children, this is the third way of arranging 6 pens. That is 2 rows of 3 pens each. And the last way of arrangement is 3 rows of 2 pen each. There are 3 rows, and in each row there are 2 pens. Earlier I showed you an example of arrangement of pens, isn't it? Did you understand what that is? That is nothing but the factors of 6. In total there are 6 pens. I arranged those 6 pens in 4 different ways, isn't it? So by that arrangement we understood that the factors of 6 are 1, 2, 3 and 6. Okay. Similarly for other numbers also we can find the factors. We'll see it later in the video. Now let's see the facts about the factors. Okay. First fact is a number is its own factor. Okay. A number is its own factor. For example, factors of 6. I'll write it here: 1, 2, 3 and 6. These are the factors of 6. A number is its own factor. 6 is a factor of 6, isn't it? Yes. Next is 1 is a factor of all numbers. Take any number, for sure 1 will be a factor. Okay. Here also if you notice, you can find 1 is a factor of 6. Next is, for a number there are limited number of factors. Okay, factors are limited, but for multiples we saw multiples are endless. There are so many multiples, we cannot count it. But here there are limited factors. And the next fact is, a factor of a number is less than or equal to the number. Let's take the same example of factors of 6. Here factors are less than the number. Here, is there any number greater than 6? No, right? All the factors are less than 6, including 6 and less than 6. Okay. And a last fact is, 1 is the only number with one factor. So factor of 1 is 1 alone. All other numbers will surely have at least 2 factors. It can be 1 and the number itself. Okay. So children, how to find factors of a particular number? So in your textbook, 2 methods are given: multiplication method and division method. That is not practically possible when it comes to larger numbers. So listen to this carefully so that you can find the factors of numbers. Okay. Here I have a question: how to find the factor of 126? Okay. So 126 is a number which is divisible by 2, isn't it? This is an even number, so it is divisible by 2. So some of you may know this method. Others, listen carefully. 126 is divisible by 2. Draw like this. Since as you do division, the same way you are doing it in a different manner, that's all. 1 is smaller than 2. So take the next number 12. How many times 12 is divisible? 6 2s are 12. 6 2s are 12. Okay? Next, we have 6. 6 is divisible 3 times. So 3 into 2 is 6. Okay? Now we got 63. 63, we can divide 63 by 3. Yes? By 3. Take the first number 6. 2 into 3 is 6. Okay? And 1 into 3 is 3. So we got 21. 21 is again divisible by 3. How many times? 7 times. 7 into 3 is 21. So we got 126 as 2 into 3 into 3 into 7. Okay? Now, how to find factors with this? 1, we have to see so many ways in which we get 126. Okay? So, 126 is 2 into 3 into 3 into 7. It is 63. Next, 126 equal to, leave this 2, take this 3 here, 3 into, take all the other numbers. 7 into 3 is 21, 21 into 2 is 42. Now we have one more 3, need not take it. Take the next number 7. So 126 equal to 7 into, multiply all this. 3 3s are 9, 9 2s are 18. Okay? Now we took only one number. Now let's take two numbers. So 126 can be written as 3 into 2 is 6. 6 into 3 into 7 is 21. And next let's take these two numbers first. So 126 is 3 into 3 is 9. 9 into 2 into 7 is 14. So multiply as we get different numbers. All are different here, right? So we got so many numbers here, and I already told that 1 and the number itself will be the factor of the given number. So 1 and 126 are already the factors of 126, and here by multiplying some numbers we got 126. So in the beginning of the class, what we told is the numbers used to multiply are the factors. So 1 and 126 are the two factors of 126, and the next factor is 2, and another factor is 63. The next factor is 3, and one more factor which is 42, and next factor is 7 and 18 6, 21, 9, 14. So all these 10 numbers along with 1 and 126 are the factors of 126. Got it? So children, we learned how to find the factors, isn't it? Now let's see whether one number is a factor of another number. So as we did for finding multiples, the same way let's do division. Okay? So to find whether 7 is a factor of 30, divide 30 by 7. So we get the quotient as 4 and remainder as 2. Since the remainder is not 0, 30 is not completely divisible by 7, and thus 7 is not a factor of 30. Okay? So children, have you heard about prime and composite numbers? Yes? Prime numbers are the numbers which has two factors, the number and 1. So if a number has only two factors such as 1 and the number itself, those numbers are called as prime numbers. The numbers other than prime are called as composite numbers. Here I have some numbers. Let's see whether they are prime or composite. Okay? I have 3 here. Okay? 3. What are the factors of 3? Only 1 and 3. So there are 2 factors for 3, which is 1 and 3. So this is a prime number. Next, let's see the next number, which is 4. What are the factors of 4? 1, 4 and 2. 2 into 2 is 4. So there are 3 factors. It's more than 2. So this is a composite number. Okay? Next, 7. What are the factors of 7? 1 and 7 alone. No other factors. Yes? So 7 is a prime number. Next we have 25. Factors of 25 are 1, 5 and 25. There are 3 factors. So 25 is a composite number. What about 2? 2, is it a composite number? No. Factors of 2 are 1 and 2. There are only 2 factors, hence 2 is a prime number and 2 is the only even prime number. Okay? Now let's move on to prime factorization. The method of finding the factors with the product of primes are called as prime factorization. So let's learn prime factorization using factor tree method. So this is how to draw a factor tree. So here I have an example, 54. 54 can be written as, it is a multiple of 2. 2 into what is 54? 2 into 27 is 54. Since 2 is a prime number, stop there and move on to the number which is composite. So 27 can be written as 3 into 9. Okay? Since 3 is a prime number, stop there, and 9 can be written as 3 into 3. Got it? So let's take only the prime numbers here. Here we have the prime numbers such as 2, here we have 1 3 and here 2 3. So 54 is nothing but 2 into 3 times. Okay, so 54 can be written as product of primes in this manner, which is 2 into 3 into 3 into 3. Okay, so children, now let's see about common factors. Okay, here I have an example of 12 and 20. I had taught you how to find the factors of 126 in this video itself. In the similar way, you can find the factors of 12 and 20. So factors of 12 are 1, 2, 3, 4, 6 and 12. If you divide 12 by 1, we get remainder as 0. So 1 is a factor. If you divide 12 by 2, we get remainder as 0. So 2 is a factor. Take any number. If you divide 12 by 4, we get remainder as 0. So 4 is a factor. And moving on to factors of 20, factors are 1, 2, 4, 5, 10 and 20. If you divide 20 by 10, we get remainder as 0. If you divide 20 by 5, we get remainder as 0. So if you divide 20 by any of these numbers, it is completely divisible and we get the remainder as 0. So we can conclude that all these are factors of 20 and all these are factors of 12. Okay? Now, what are the common factors of 12 and 20? 1 is common, 2 is common, 4 is common. That's all. So 1, 2 and 4 are the common factors of 12 and 20. Okay? So children, we learned about common factor. Now let's learn highest common factor, that is HCF. Okay? So I have the same example here, factors of 12 and 20. We already got the factors as this and the common factors were 1, 2 and 4. So which is highest among them? Yes, it is 4. So the HCF of 12 and 20 is 4. So this is how we do HCF, by listing the factors. Okay? So children, I have one more example here to find the HCF of 24 and 36. So let's prime factorize it. We can do by factor tree method also. I am doing it in this way. Okay? So 24 is divisible by 2. Isn't it? 1 into 2 is 2. 2 into 2 is 4. Okay? And 12 is again divisible by 2 6 times. 6 into 2 is 12. Again 6 is divisible by 2 3 times. Yes? So 24 can be written as 2 into 2 into 2 into 3. Multiply all these. Okay, 2 into 2 into 2 into 3. Now let's factorize 36. 36 is also divisible by 2. So 1 into 2 is 2, but this is 3. So take that 1, 2, 6. So 6 will become 16. 8 into 2 is 16. Or else 18 into 2 is 36. Okay, and 8 is again divisible by 2 9 times. 9 into 2 is 18, and 9 is divisible by 3 times. 3 into 3 is 9. So 36 can be written as 2 into 2 into 3 into 3. Now let's see what are the common factors. Here 2 is common, one more 2 is common, and 3 is common. Okay, that means the common factors are 2, 2 and 3. Now multiply all these. 2 into 2 into 3. So if you multiply we get 12. So the HCF of 24 and 36 is 12. Got it? So children, now let's see the relationship between HCF and LCM. Okay, what is the relationship? If you multiply the LCM of two numbers and HCF of two numbers, we would get the product of the numbers. Okay, let's take two numbers 8 and 12. Okay, and find the LCM of 8 and 12. The LCM is 24. The lowest common multiple of 8 and 12 is 24. And the HCF of 8 and 12 is 4. Highest common factor of 8 and 12 is 4. Now let's multiply the LCM and HCF. When you multiply, we get the product as 96. Okay, the product is 96. What is the product of 8 and 12? The product of 8 and 12 is also 96. So we got that the product of LCM and HCF is equal to product of the given numbers. Here the given numbers are 8 and 12 and the product is 96, and when you multiply the LCM and HCF also we get 96. So the answer is correct. Now let's see the tests of divisibility. Okay, so if you know the divisibility rules, then it will be easy for you to understand if a particular number is divisible by another number. Okay, so here let's see the divisibility rule of 2, 3, 9, 5 and 10. Okay, so how to know whether a number is divisible by 2? If the last digit of the number is 2, 4, 6, 8 or 0, we can conclude that that number is divisible by 2. Or if the number is an even number, then you can conclude that that number is divisible by 2. What about divisibility of 3? We have to add the digits of the numbers. Here I have 165. When you add the digits 1 plus 6 plus 5, we get 12. 12 is divisible by 3. How many times? 4 times. So we can conclude that 165 is divisible by 3. Similarly, when you get any number, you add all the digits, and when you add, if you get a number which is divisible by 3, then that particular number is divisible by 3. Okay? And divisibility of 9 is also similar to that. I have an example of 162. When you add the digits of 162, we get 9. 9 is divisible by 9. Or when you get any number, take that number and you add, for example 729, add all the digits, we get 18. 18 is divisible by 9, so 729 is also divisible by 9. Okay, and divisibility of 5 and 10 are very easy. To know whether a number is divisible by 5, look at the last digit. The last digit is either 0 or 5. Then that particular number is divisible by 5. And what about divisibility of 10? If the last digit is 0, then we can conclude that that number is divisible by 10. The last one, let's see the divisibility by 4. How to check a number is divisible by 4? We have to see the last 2 digits of the number. Here I have 408, take the last 2 digit 08. Here I have 3100, last 2 digit are zeros. Here I have 4728, last 2 digits is 28. So if the last 2 digits are divisible by 4, then we can conclude that the whole number is divisible by 4. Okay, here 8 is divisible by 4, here 28 is divisible by 4. And there is one more condition, the last 2 digits are 0, then we can conclude that the number is divisible by 4. So the condition is the last 2 digits should be divisible by 4, or the last 2 digits should be zeros. Okay, so all these numbers are divisible by 4. So children, I told you about alarm clock, isn't it? So take 2 phones and keep alarm for a particular time and keep different snooze time for both the alarms. Okay, and then find at what time both the alarm ring together. Okay, and what else we learned in this video? We learned about factors and multiples. Under factors we learned common factors, HCF. Under multiples we learned common multiples and LCM. What else we learned? We learned about prime factorization, prime and composite numbers, relationship between LCM and HCF, and also tests of divisibility. So take care. Bye.